skeletal, and then from one position to the other position, path planning, assuming a closed environment.
See, the technology works in this way that every time you are taking a step, there are, can I go a little technical to answer your question if you don't mind?
With GPS, your position can be obtained in terms of latitude and longitude.
Lat, long, and elevation.
Right. In other coordinate system, when you say Cartesian coordinate system, X, Y, and Z positions, or equivalent positions, assuming that this is one house which has no interior elements, assume, we want to work out such a situation where the drone has to enter from that door, take that way, and then take another entry from that door.
See, if it is a known environment, everything is possible. If it is not known, you need to know the environment. So that's where basically the responsibility of the sensors are to actually identify the environment. So if you give me the environment which is known and very precise, it is possible. If it is not known, you need to put a sensor which can identify the environment.
Earlier role, he worked in Hong Kong at Credit Suisse as Assistant Vice President. He also co-founded Crazy Travelers. Please come on stage, sir.
What I'll do is I'll keep this very short. Okay, like these two guys have covered UAVs and what you can do with it in intense details. So what I'll do is I'll kind of shorten my presentation in a 2.5 minutes to 3 minutes of a video. That will kind of cover like a good, how do you say, what's the word? Like the essence of the whole presentation, and then we'll see the next part. I don't think that. Okay. No, it's okay. So the last guy, I don't know if you liked his dance or not. If you did not, don't judge him. He's a much better coder than he's a dancer. For those of you who missed the the video because you went on a washroom break. I'm going to consume like the next 15 minutes of your mind space. I'll try to keep it brief so that we spend a little more time talking to each other rather than, you know, me trying to tell you stuff. All right, so here's us. We are Drona Aviation. We are India's first, and I believe presently the only nano drone company. We are working with the vision. Am I walking here? We're working with a vision of building a robust ecosystem that will foster drone innovations. As Vipul was saying some time back, the government or its interference is not letting the talent in India foster at a speed that it can, and that is exactly what we are looking to challenge here. How do we do that? We're looking to do that through our nano drone platform. Now, what's the problem that we are looking at? You essentially have consumers who buy drones for an experience. Not the industrial consumers, but like the retail consumers. They buy drone for an experience. Could be just flying, could be photography, could be racing, or a bunch of those. For each of these, they have to buy a new drone or a new system, and that is what we are looking to change. On the developer side, which is where my team comes from, we've been working with drones for almost 7 years now. The drone systems to work on, to build on, are just very expensive at this point of time. They're getting cheaper, but they're still pretty expensive. And the cost of failures are really, really high. The worst part of this is, if you happen to build something that's like super cool, there's just no way you're going to be able to share it with anyone out there in the world. You'll probably take a few videos and put it up on Facebook, but nobody else will be able to adapt what you have built into their systems. That is what we are looking to change by the Pluto Explorer platform. It is essentially a robust nano drone. It has a software development kit that allows you to work modularly, not only with the remote control, which is where like a bunch of drones today work with, where you program the remote control to do stuff. But the SDK will allow you to very easily work with the firmware also. And most importantly, the third part is the fact that the drone is controlled by a phone app, which will allow the developers to build stuff on top and then share it with not only other developers, but layman consumers who are out there. So that on the consumer front, he gets to get more and more use cases on the same hardware, whereas the developer gets to build cool stuff and share it with the world. Now, I believe Vipul and Suman have spoken significantly about the market, but you see the estimates of how big the drone market can be have been exponentially growing over the past few years. Back in Feb 2014, they said it could potentially be $2 billion market. And then over the last 3-4 years, there was this recent PwC report which said that the industrial drones could be worth $127 billion. And we cannot keep catching up. We need to work. We need to move fast to capture a chunk of that market. Having said that, we are not looking at the industrial part of the drones. We are looking at only a very small, cute section of nano drones, wherein we've had use cases like Parrot, Make Block. There was a company called Zano that tried coming up. They had fantastic pre-revenue, but they didn't kind of make it. Even today, if we focus on the nano drones itself, we can look at a global market of $2 billion presently that can grow up to $10 billion. And this is not just for the consumers, but also for industrial. And yes, there are and there can be industrial use cases for nano drones too. Which brings me to the first product that we have, the Pluto nano drone. It is a DIY kit, a DIY drone that you build yourself, which you can wirelessly program. And once you break some stuff, you just modularly replace parts of it. To give you an idea of what it is, it looks something like this. And let me see if it flies. So essentially, instead of going on a walk with your dog, you can just take your Pluto and walk with it. It's integrated with your app. So the pressure sensors take care of its height, and the accelerometers in the phone take care of the remaining XY movements. Now that you have an idea of what we are building, yes? Right now, or should I do it later? Okay, I could do it now. Okay. All right. Oh, sure. Now, this is something that we have brought out to people because there are two problems. One is there's always the concern of how is the government going to look at the drones, and secondly, a drone can be an expensive thing. What if I crash it? What if I break it? You know, that's the issues that we are addressing with this one. You get to work on it, you get to develop on top of it, you build some cool stuff on top of it, where you don't have to fear about the high cost of failure. You don't have to also fear that if you're flying this, the government will probably come and put you in jail. So with that, in fact, a good bunch of people who have bought, I believe how much? More than 800 of our drones have been people who wanted to start doing something with drones. You know, they wanted to probably go to Vipul and buy his drones for for surveying or something else, but they were a little concerned as to how do I know what's going on inside, before I make such an investment. So they buy my drones, they fly it, they crash it, they break it, and then they fix it again, and then they fly it, and then they crash it, and they break it again. And once they have undergone these cycles a few times, they go to Vipul and buy his drone. So that's about us. We also have interacted with more than 2,000 people who built our drone through workshops or through other places. We are also now up on Amazon, eBay, our own website, they're selling. Now here's where the interesting part comes in. We're working with developers who are looking to model the real life problem statements in a lab setup. The idea is if you can build algorithms that target these real life problems and you can formulate them, you can then go ahead and extrapolate them out in the open air scenario. So that's why we have IIT Bombay that's working with Plutos, building for their competitions as well as in their labs, in their systems controls labs. We also have, so we had Capgemini that was prototyping some of its warehouse monitoring ideas with Pluto. And we also had a security company that was looking to build a closed space security drone in their systems. So those are the developers that we are working with. We're parallelly working with a lot of educators who are conducting STEM education using drones because, well, drones are fun. And we also are collaborating with one person who's a supply chain management company full-time into warehouse. They are again looking at some warehouse-specific solutions using drones. Again, since it's a closed space, they would rather go with nano drones rather than the big ones. And well, you also have a toy maker who's trying to build, low-cost toys here in India instead of just importing them from outside. The customer feedback has been fantastic. It's extremely robust, very stable, and very simple to build. The next steps which come for us is the Pluto Explore, the one which I showcased in the beautiful video that we played earlier. It's essentially going to be Pluto, the DIY drone, with an integrated camera. And here's where the fun part comes in. It'll also have something called as a unibus. The way you have USB for a computer, you'll have unibus for the drone, where you can modularly add all sorts of hardware on top of it without having to worry about which kind of connection is it, UART, is it serial port or what. With the same ease that you attach USB to a computer is the ease with which you will be able to attach newer hardware. This hardware could be something that's as simple as a high-speed module for racing, or an actuator for the drone to fly somewhere, pick something up, go somewhere else and drop it. Or it can be something a little more serious, where you have in IR sensors coming in, distance sensors, thermal cameras, and yes, there are thermal cameras that are so light, which can be added on to the nano drones. So these can be added on top of the Pluto Explore drone. In fact, we have had, we spoke to the security forces earlier, both the police, the Force One, which is like the energy equivalent of Maharashtra Police. There was also interest from NSG itself. In fact, a couple of people from L&T Defense had spoken to us with a very specific use case for a nano drone in the operation zone. But then, well, Vipul would probably know how fun it is working with the government and, you know, trying to get them to pay you. And when you are a startup, it's probably not a luxury you can afford for some time. The idea behind doing this is, if we can get 1,000 or 5,000 people working on this platform, you will have so many more efficient solutions that will come out, which will actually allow us to compete with the likes of China or US. All the government has to do is, well, not block or not ban. You've seen that with the IT industry. The IT industry was given a free hand to grow, and it's created wonders. I mean, that's what the government should be doing with the drone industry. And that's what, well, I personally am betting on in some years to come. Coming back to Pluto Explore, right? We are also looking at, so that I spoke about the hardware features that we're adding onto the drone. We'll be also adding a software development kit, as I said, which will allow you to work with the firmware and the remote control for you to build specific use cases. And you'll also be allowed to share what you have built with everyone out there who has a Pluto app on his phone and maybe a Pluto board where he can try out multiple things on top of it. This Pluto Explore will allow infinite possibilities to come out of a drone. It could be something as simple as a racing drone. It could be something as simple as, you know, as I said, fly somewhere, pick up, drop. It could be, again, something fun like a camera drone, which is seamlessly integrated with Snapchat or Instagram. And then you can look at something a little more complex like swarm applications. You were talking about flying in closed spaces and how do we do that, right? You were asking a question, right? I would have gone with an instinctive no answer to it, but he had a little more measured response to it. Having said that, we are still working with a closed space localization system, which can give you that sort of autonomy that you're looking at. In fact, that's what we are working with IIT. Having said that, if you can build this platform and a forum for people to work with each other, 50, 100, 1,000 different ideas can come out of it, out of which probably, you know, 20, 30 might be successful. And, you know, that is what we are driving all our work towards. In fact, what we are hoping is, if not like brilliant ideas, Vipul will have fantastic people to hire after, you know, people who have used Pluto Explore, and Sumanth, who's presently looking to import drones into India, would probably think, hey, maybe we could just build something in India and get, you know, sell it to the government, right? And again, so coming back to the regulatory front, this is what has helped us go on for a while. If you check out, the US FAA has already issued the regulations which clearly state, well, which state that flying in closed spaces is okay, as well as drones that are lighter than 250 grams are exempt from the restrictions of the regulation. And we have been speaking to the police, to the DGCA, and we have been later just going them saying, I'm going to fly something in closed spaces, do you have a problem? And they said, like, just go ahead. I just said, just don't do something stupid, and we said, we're fine. In fact, that's what has helped us go to where we are right now. That's just my team. So you see two smart guys next to my side, so they are the smart guys who build all the cool stuff and I take credit for it. So that's them. And to the extreme right, you have the guy who was dancing. As I said, he's a much better coder than he's a dancer. And I would kind of wrap it up at that. You wanted another drone demo, so let me kind of quickly fly one for you. Should I? Any of you who wants to try flying? Yeah. In Z axis, yes. In XY, I cannot because it does not have any localization to tell it where it is. Yeah. So can I get another battery very quickly? I kind of forgot to charge it earlier. Uh, 6499. Android app is free. The iOS app is also free. And say what? You don't require a charger for this. You just require your phone charger that goes with it. It takes care of the EA. Okay, so why don't you come over? I'll quickly give you a crash course of how to do it. Okay? I'm pretty sure you would have flown quite a bit of drones until now, but just in case.
Each drone is different, right?
So that's the front, okay? And what I've done is I've had the accelerometer integrated. So to control it like this, just do this. This for up, down, that's it, okay? So you arm this, drag it all the way down, goes up, and then you kind of control it, okay?
Hopefully test the stability also if it falls. I speak for myself, not for Intel now.
You want to hold your phone like this because it will give a, yeah,
Is this better?
this is much better. बिंदास आने दो ऊपर, हाँ, जाने दो आगे, नाइस, अभी उसको छोड़ दो. Could walk out. So this one flies for around 7.5 to 8 minutes. Now we are working with a different frame, with the same board, same motors, and a different frame and a different battery. The present tests have gotten us 12 minutes of flight time, but we are looking for something even, like we are trying to push it even further than that. The range is around 100 to 150 meters. It depends on your phone. Like, that's okay, let it crash. It actually won't hurt anyone. Sorry, to come back to you, theoretically it should give us around 200 meters. Practically we have seen it gives us anywhere between 100 to 150. Also depends on your phone. Like my previous phone had crashed so many times, so it didn't give as good a range. It'll just land itself because it does not have a localization system.
From the start of the flight,
Yeah.
till lands,
Uh-huh.
Is it just flying, or can you even able to store the points of its navigation?
Right. So this one, we do not have any sort of localization system in this room, right? And this one does not have a GPS on top of it. If there's some sort of localization, that is a time when you can start logging this data.
This is just for fun, having fun.
No, this is, yes, this is primarily for fun. It's also used for teaching. As I said, we have three sorts of people who use this: hobby guys, then people who want to start doing drones, start their drone journey but don't know where to start at, and third, which has been like a big chunk of us, which is students. Students who want to learn physics and electronics in drones, they work with this, and a lot of college students who want to build their college projects on top of this. So, like, that's the path we are looking to take in the developer journey. Yes. Uh-huh. Uh-huh. Mm-hmm. Uh-huh. 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 Yes. Correct. Uh-huh. 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 Correct. Correct. Now there's a slight problem with that. We have explored that part, but the Wi-Fi based or Wi-Fi tag based localization gives you an accuracy of around 2 meters, which is not good enough for us. It may include bias, but it's still not good enough. So we are working with a camera based localization system, which will give you its XY coordinates, and a laser based, which a laser sensor, which will give you the Z coordinate of the drone. So that's what we're working with IIT Bombay right now. Any more questions? Yeah. Uh-huh. 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 Correct.